Hi everybody, let me quickly share my screen. I hope my screen is visible. So today I am here to present my project. This is a classification based project, namely coronavirus tweet sentiment analysis. This is a type of classification project, as I said, and this my name is Pratik Kanjilal. I have personally contributed this project to the open source. So let us see first what I have done in this project. So basically, we have been given the Twitter data during COVID-19 pandemic phase of the 2 to 3 year span from 2019 to 21, maybe. And these tweets from Twitter have been collected and they have been encoded very carefully so that the privacy of the users are still intact with them. And these tweets in the form of a data set, we are using this as a training data for our models. So we are going to do this project, and this is a type of NLP, natural language processing project. So let's dive into the project. The problem statement is to build a classification model to predict the sentiment of COVID tweets. There are lots of tweets, and we need to predict the sentiment of that tweet, whether it is a positive sentiment or it returns a negative sentiment or a neutral tweet. So we need to classify this problem that we need to do some sentiment analysis. So let's begin and let us first import our libraries. I have imported some basic libraries and some basic NLTK libraries also, and I'll be importing in the process also. Now coming to the mounting of Google Drive, I have mounted my Google Drive over here. And now I have loaded the data set into a pandas data frame, namely data, using the function pdreadcs. So let us have a look at our data set. This is the first look, and these are the columns: username, screen name, location, tweet at, that means the date of the tweet, and the original tweet. This is the textual column we have over here, and we need to deal with this textual data and the target variable, that is the sentiment. Either it is neutral, positive, or negative. Currently, there are two more sentiments like extremely negative and extremely positive. So we are going to deal with that also. And now look at the shape of the data set. This is something 41,000 plus rows and 6 columns. And let us gain some information about the data set. This is the username. This is the screen name. These are non-null objects and of integer types. And other columns, all the columns, the remaining columns are of object data type, that means string data type. And we check the duplicate values also. The length becomes 0, that means there are no duplicate value, and missing values also. So we check over here that in the location column we have about 20% of the missing values. So we need to deal this and handle these missing values very carefully. Let us have a look at the heat map, and the black part is filled with data, the white part are the missing values. So we have a 20% of null values in the location column, and there might be some tweets which the user did not mention the location in those tweets. So those tweets are of null values. Now we need to handle this. So we cannot directly drop the tweets because of the weightage of the null values. It is 20%. So it's if we drop this 20% of the null values, we are going to drop 20% of the tweets also, and we are going to drop a hefty share of our training data also. So I want my model to be generic, so that's why we need to handle it carefully. And look what I've done. I have just placed a string unknown in the place of the null values for the location call. If the location is not there, then it will be reflected as unknown. And let us have a look at here. We see that there are two null values there were previously, and now it is converted to unknown. And just have a look at the counts. We have 8,590 unknowns, and that is comparatively very, very high compared to all other locations. So we cannot just simply drop this null values. We need to handle it carefully. Now, if we plot that, we see a lot of big graph for unknown tweets, and then followed by the London and all those parts. We are going to compare other locations, except excluding the unknown part in the EDA part, in our EDA activities. Now coming to the EDA, we firstly do the count plot of top 10 locations, excluding the unknown locations. So we see over here that London comes out at the top, followed by United States, and again London, England. So there might be some duplicacy in the entry of the data. Then New York and so and so. And India comes at the second last for top 10 locations. And now coming to the next visualization, this is the bar plot of proportion sentiments. And we see the sentiments, different types of sentiments and their proportions over here. The maximum out of this is the positive sentiment. Then there is a negative, there is a neutral sentiment, and there are two more sentiments like extremely positive and extremely negative. Now, coming to the third chart, we have a pie chart to display the proportion of sentiment. So we see after converting these extremely negative and extremely positives into positives and negatives and positives respectively, we have only three sentiments over here. We do the pie chart distribution to check the share of each sentiment, and we see positive of 43%, neutral of 18%, and negative of 37%. And now we are displaying the most important or most frequently appeared words in the tweets by using a word cloud over here. And we see coronavirus, that is quite expected that it would be a very common word like COVID. We have consumer, online, pandemic, and all those things. Grocery store is quite an important word over here. And sanitizers and all those COVID related stuffs. Now coming to the line chart display of the tweets across time. So we see over here from 1st of April 2020 till 27th of uh, you know 320 that is March. So we have data till this time frame, and this is the graph, or you can say you can call line chart over here to display the counts of tweets across time. And we see the peak value over here nearly between 17th March to 22nd March. And let's see, for the histogram parts, we are going to check the lengths of the tweet and their distributions, the distribution of the lengths of the tweet. So we see a histogram like this, defining the lengths and the counts of the tweets. Now coming to the feature engineering and textual data pre-processing part. So firstly, we are going to deal with NLP. So we need to do some basic NLP steps, pre-processing steps, and these are the steps. Firstly, I'll be lowercasing my data. All the words in the columns have to be lowercase. Then I'll be removing punctuations, okay? And from original tweets like the full stop, commas, and all those nonsense characters. And now I'll be replacing these HTTP, S plus, and all those things which we do not require, the links and all those things from this data set. Now we define clean tweets over here. and apply the remove punctuations and remove URL parts. And here we are specifically removing URLs once again in order if we in case we miss something in the previous step. And now we see there are no at the rates or taggings or links, etc., over here. This is a clean type of data column we have here. Now we are replacing the special characters also over here. So this is the clean tweets column. There are no, this column is without any kind of links, special URLs and special characters. And now coming to removing stop words. So firstly, I have downloaded the NLTK package over here and stop words also for English. And then I'm defining a function of removing stop words, and then I'm just applying it using the lambda function to that remove stop words. And this is how the clean tweets looks like. They have been tokenized also, and the stop words have been removed. Now coming to the next part, this is stemming, and I have used over here Porter stemmer. We can use snowball stemmer also. So Porter stemmer generally I preferred over here for this project, and this is the stemmed part. We are creating a new column itself for the stemmed data, and coronavirus, Australia, World War. This is how this data looks like. So as we can see, the words have been stemmed. And then after using that Porter stemmer, I have decided to lemmatize those words to bring back those words to its original form, like this. Before it was like this advice word did not have that E part, but it has been converted into its root form. So this is quite helpful. You know, after using Porter stemmer, I have used lemmatizing for this project. Now we'll do some feature manipulation and selections. So we are again clubbing together this extremely negative into negative and extremely positive into positive, and we're going to replace those columns. Now the final feature engineering part of the data splitting. Here we use the lemmed part, that means the finally pre-processed part, and for the you know in independent variable, and the dependent variable is the sentiment. Now we are applying train test split with 70-30 ratio over here, and we are applying stratify function also in order to handle if there is any class imbalance case. Now we have a train shape and test shape. So this is the training data, and this is the shape of length of testing data. And now we print out that how this training data looks and the testing data looks. So this is how the training data set looks like, and this is the testing data part. No, sorry, independent variables for the training data only. These two parts are of training data only. These are the independent variables, and these are the dependent variables. Now we are going to apply a machine learning models on it. So I have used, the mod 5 unique models, namely logistic regression, decision tree, random forest, XGBoost, and somewhere SVM also. So for each vectorizers, count vectorizers as well as DF IDF vectorizers. So let us see. Firstly, I have used logistic regression with count vectorizers using grid search CV. So this grid search CV allows us to do some hyperparameter tuning for getting the optimal conditions, optimal parameters for the model. So this model in generally will give the best results uh, using the optimum parameters. So this is the set of parameters I am passing through a dictionary, and I am just fitting the model into grid search CV over here. So this logistic regression model we have imported over here, and we are fitting this with CV15. So this will be a 15-fold CV. And we get the results. This is the confusion matrix, and we get an accuracy score of 78% for logistic regression. And we see over here that these are the confusion matrix charts, and these are the neutral values which are predicted and are actually neutral. There are some values which have been predicted wrong by the model also. So this is how a confusion matrix looks like. Now coming to the next model, this is a decision tree classifier with uh, count vectorizer, and we apply the decision tree over here, and we apply cross validation also. So this is a five-fold CV. Since this is a tree-based model, we are using less cross validations because the data set is large. The execution time required we run over here is very long. So we get an accuracy of 69%. And this is how the confusion matrix of decision tree model looks like, using count vectorizers. So now coming to random forest model over here using count vectorizer, and we see there is an accuracy of 74%. And this is how the confusion matrix of the random forest model looks like. Now coming to the XGBoost classifier of using count vectorizer, this is how the accuracy looks like of this model. We are doing the same steps for each and every model, and this is how the confusion matrix looks like. So this model gives out 76% of accuracy. And now coming to the model 5 SVM with CV. So this is the support vector machine. So support vector classifier over here. So we are going to fit the data, the X train and Y train over here, and we are going to predict using the X test column, CVX tests. And here we end up getting something like this. This is the array. So we need to inverse transform this data into the values, like one refers to positive, maybe two refers to negative or neutral. So we are going to get these values. Here we are getting an array of numbers as a prediction. And after converting, we are calculating the accuracy over here, and we are getting 76% of accuracy for this model. And this is how the correlation sorry, the confusion matrix looks like. Now, these are the models I have used for predicting the sentiments and using count vectorizer. And there is another vectorizer called as TF-IDF vectorizer. These vectorizers are a type of matrix, or you can call matrices, in which we convert the textual data into numbers and we pass it to the machine or the models. So for here also I have used the same number of models and same similar models. And for TF-IDF vectorizer, I have used logistic regression again. And here I get an accuracy of 77%. And this is how the confusion matrix looks like. Similarly, for decision tree classifier using TF-IDF, similarly, we get a 60% accuracy over here. Again, we have a confusion matrix for this also, and followed by XGBoost classifier using TF-IDF. And we have an accuracy of 60% using this model. And this is how its confusion matrix looks like, followed by random forest using TF-IDF. And this gives again 60% of accuracy. And this is how the confusion matrix looks, followed by the last model, that is SBC using TF-IDF. And this model gives out 76% of accuracy. And this is how the confusion matrix looks. So these are the 5 models for each vectorizers. For 2 vectorizers, so I have used 10 models over here. So every model has its unique accuracy scores. And now we are going to compare that which model performs the best, and that becomes our best selected model. So we have the chart over here, and we see that logistic regression using count vectorizer has the highest accuracy score, followed by logistic regression again using TF-IDF vectorizer. And then these are the values for other models. So here we clearly see that the logistic regression has the best results among all the other models I have used over here. So I have selected this model as our final model. And hereby I conclude my project. There are some conclusion terms over here that logist and like the size of the data set we first encountered with, and then how we encountered with the null values and how we handled them. Then this is the way I have handled them. And then again, we required only two columns out of this whole data set. So we dropped all other columns and selected only the original tweet as the independent variable and sentiment as the target variable. And then we have, you know, feature engineered and reduced the features in order to avoid problems regarding multi-class classifications. And here there is a tweet timings that from which time till which time we have the tweets over here. And this is what I have just explained over here, that all the models with and some models with grid search CV also using, I have done some hyperparameter tuning there. And then I concluded that logistic regression model has given me the best results for both type of vectorizers, but the best results have been pulled out by the count vectorizer. So this was all from my side. Thank you very much. Thank you. This is my project. I am concluding my project over.